हाँ सर।
यस, मैं आपको जो क्वेश्चन भेजे उनके आंसर बताइए आप। एक तो हो ही गया है, दो तो हो गए।
सर एक क्वेश्चन तो था डिटरमाइन स्प्लिटिंग एनर्जी, वो हो गया।
यस।
D5 फॉर्म ऑक्टाहेड्रल कॉम्प्लेक्स टेट्राहेड्रल कॉम्प्लेक्स CFC0, ये भी हो गया। और एक्सपेरिमेंटल वे से एंथैल्पी कैलकुलेशन कैसे करें? तो to calculate the enthalpy change experimentally is done by this equation. In this case, the equation is del H equals to m into S into del T, where m is the mass of the reactant, and S is the specific heat of the product, and del T is the change in temperature. So by this equation, we can calculate the change in enthalpy experimentally. Can you see, sir?
Yes, each formula.
There are some
EM
other
del T, yes.
MS del T, ये ठीक है ना?
Yes, right. Yes, good. Yeah, next also
हाँ,
move on coordinations. Yes, what the main application of Werner theory application? Any uses? Any example?
sir, okay, sir. The use of Werner theory is basically to know the how structure is formed for a coordination complex. The structural idea of coordination complex is given by the Werner theory, because from Werner theory we can get the actual insight how a coordination complex is formed, because there are some ligand which are attached with the central metal atom, and there are some spectator ion. So the spectator ion added to the primary valency of the central metal ion, and the primary valency is the oxidation state of the central metal ion, and the number of ligands attached to the metal is called secondary valency. So this is the basic fundamental concept for the coordination complex, the structure of a coordination complex, which can be applied or which can be understood by Werner theory. Formation of a coordination complex, or the structural aspect of the coordination complex, is known by the Werner theory.
Is any drawback, limitation of Werner theory?
Sir, in case of Werner theory, we cannot know many aspects, or like the color or the stability, or how the magnetic moment of a coordination complex occur, or a coordination complex is paramagnetic, diamagnetic, or ferromagnetic, or whatever magnetism it shows. We cannot know anything about from Werner theory. Werner theory only tells us about the structural aspect, like the secondary valency and primary valency for a coordination complex. This will be the limitation for Werner theory.
Yes, good. Yes, what the main application of ligands in chemistry? Explain.
Sir, ligands are the species which can donate its electron to a particular metal ion, or rather we say in case of coordination complex, ligands are the one which donates its electron to metal and creates a coordination complex. So like a complex, let's say complex is Ml6. So this complex is made by the interaction between metal and ligand. And in this case, there are some cases where charge transfer is taking place with some exceptions, but generally when we see a coordination complex, we see that there are a vacant orbital of metal and there is a fully filled orbital of electronic fully filled orbital of ligand. The fully filled orbital gives its electron to the vacant orbital of metal and creates a bond, and that's how a coordination complex is made. So this is why ligands are very important, and so more like ligands are the nucleophile which donates its electron to make a complex, and to make a complex, after getting to a formation of a complex, the complex is much stable than its previous form because of the hybridization it took place. So this is how ligand is very important in our chemistry.
Yes. Next, move on IUPAC. What the main application of IUPAC nomenclature?
So the main application for IUPAC nomenclature is we can predict the structure of a molecule or a coordination complex in case of by the nomenclature of IUPAC. It can shows us the oxidation state of the central metal atom and the number of ligands are attached to a metal, and also the spectator ions or the ions which are not present in coordination sphere can also be told by the IUPAC nomenclature. So this is the application of nomenclature in coordination chemistry.
Yes. What is isomerase? What the main application of isomerase? What the difference organ inorganic isomerase? Any example of isomerase?
Sir, in case of coordination chemistry, there are stereoisomerism. There are two types of stereoisomerism. Two types of isomerism. One is structural isomerism and one is stereoisomerism. So, in case of structural isomerism, we are seeing that there are some isomerism which is present in the basis of the atom to atom connectivity. In structural isomerism, the atom to atom connectivity is different, while in stereoisomerism, atom to atom connectivity is same, rather the spatial arrangement of the metal spatial arrangement of the ligands are different. So in case of structural isomerism, we can see linkage isomerism, hydrate isomerism, ionization isomerism, coordination position isomerism, and so on. And in case of stereoisomerism, we can see geometrical isomerism and optical isomerism. So in geometrical isomerism, we can see cis-trans isomerism. In this case, when a molecule or a ligand are staying besides each other, then it will be called as cis isomer. And when the complex is completely positioned in opposite places, then it will be called as trans isomer. So this type of isomers and this type of isomerism creates a variety of molecule which can show different properties in case of coordination complex. And in case of structural isomerism, we can see there is a difference in linkage, like use of ambient nucleophile like SCN or NCS, and also there is some hydrate isomerism where the ligand H2O is different from each other in case of isomerism. Whether in this case the empirical formula of the compound is same, but the structure is different somehow. So these are the most of the application part of coordination isomerism.
Yes, any example of geometrical isomerism?
So this is the cisplatin and transplatin. So in case of cisplatin and transplatin, we can see there is a geometrical isomerism where Cl and Cl is in case of trans are completely in opposite position, and in case of cis, this is sitting behind each other. सर ये सब तो आपने पूछ लिया था पिछले दिन.
यस, पूछ लिया था, लेकिन एक डिवाइस चल रहा है ना. यस, नेक्स्ट बताइए. थ्योरीज बीवीटी और एलएफटी सीएफटी, इनका क्या डिफरेंसेस है?
Sir, so in case of BBT, it is the theory which describes chemical bonding, and BBT states that the overlap of incompletely filled atomic orbital leads to a formation of a chemical compound, but between chemical compound between two atoms. The unpaired electrons are shared in this case and form a hybrid orbital, by which hybridization occurs and it will form a coordination complex. So by sharing electron, BBT shows us the formation of coordination complex. But in case of CFT, like crystal field theory describes the orbital degeneracy of the transition metal complexes. Crystal field theory describes the orbital degeneracy of the transition metal complexes due to the presence of the ligands. CFT, in this case, CFT, the energy system of the coordination complex is altered when a ligand metal interaction happens. So in case of CFT, we always see metal ligand interaction, which further affects splitting of d orbital. So splitting of d orbital creates the theory for the color, in which splitting of d orbital, there is a gap of between two orbitals, and then for those gap, the electron, the energy releases, and we can see the color for a compound. But in case of LFT, or like ligand field theory is more of a perfect theory, or more preferred, because in case of CFT, metal and ligand are used as a point charge, but in case of LFT, both it considers both ionic and covalent aspect of a complex. LFT describes the bonding, orbital degeneracy, and electronic structures of a coordination complex. It represents an MOT to the molecular orbital theory to the transition metal complexes. And LFT is resulted after the mixed theory of molecular orbital theory and crystal field theory. So these are the primary differences and the most important theories of coordination complexes.
Yes. Yes, what the main application of orbital diagram and Tegano-Segano diagram? Main application.
Okay, sir. So orbital diagrams are used as a as a correlation diagram, and it shows the different energy states of a ground state turn of certain configuration of a d orbital complex. So according to the orbital or orbital diagram, we can see how the energy state are splitted, and it shows the electronic transition. So firstly, we are seeing in case of octahedral and tetrahedral, we can use this type of graph, or this is the diagram of energy diagram for a coordination.
Yes.
So this graph is for D1, D9 tetrahedral and D1, D4 tetrahedral and D9 . The left side of this graph shows the D1 and D6 tetrahedral structure, and also for octahedral it will show the D9 and D4 octahedral structure. So this part of this orbital diagram shows this configuration, shows the energy states of this configuration, and in case of the right side, D9 and D4 tetrahedral and D1 and D6 octahedral is shown. So this is how we can see by orbital diagram that there is one transition can be possible in this case, because there are two energy state possible in case of this conformation of coordination complex. So this is one diagram, because why we have plotted this diagram, because the ground state turn of D9, D4, D1, D6 is D, and for D we have seen that the Mulliken turn symbol is shown as E and T2. So if octahedral we use G, T2G and EG, but when it will be used as tetrahedral complex, we do not use G, as tetrahedral complex doesn't have any center of symmetry. So this is why no GRAD or no G will be present for tetrahedral complex. So this is how we can predict the energy states of certain configuration by orbital diagram. And orbital diagram are most of the cases, and it is used for high spin complexes, but Tanabe-Sugano diagram is used for both low spin and high spin complexes also. Now I am plotting the other type of orbital diagram, which is basically the other configurations. So this is the plot, and in this case we are talking about D2, D7 and D8, D3, and in this part D8, D3 D tetrahedral and D2 D7 octahedral. So for this type of configuration, the ground state term is F. So for F, the orbital diagram will be looking like this. So we know that for the spectroscopic term F, the molecular terms are T1G, T2G, and A2G. T1, T2, and A2. And this is T1P. This is also T1P, and this is T1. This is T2. This is A2. So this is the final orbital diagram for the rest of the molecule shown in this case. By this, we can predict the transition of electron according to the different energy state. This is the application of orbital diagram and Tanabashwara diagram.
Yes. एक एग्जाम्पल लिखिए आप आइसोमेरिज्म का COCl2
COCl2
En का होल ट्वाइस किलेटिंग लिगेंड है इथाइलिन डाइमीन En होल ट्वाइस कोष्टक 1 एंड Cl बताइए ज्योमेट्रिकल है कि ऑप्टिकल आइसोमेरिज्म या बोथ है
COCl2 En होल 2 और उसके बाद क्या
Cl
बाहर Cl वो ब्रैकेट के बाहर Cl
यस
ओके सर इसके पास तो जियोमेट्रिकल भी होगा और ऑप्टिकल भी होगा
यस ज्योमेट्रिकल और ऑप्टिकल दोनों होगा
देखते हैं हाँ सर जियोमेट्रिकल ऑप्टिकल दोनों होगा So this is cis, this is trans, and the cis has a mirror image. So both of these are enantiomer. So the total stereoisomer will be 2 plus 1, 3.
Yes, good. Right. Yes, last day हमने discuss कर लिया था. The next move on chemical kinetics. Your topic is chemical kinetics, no?
Yes, sir. हाँ.
Yes.
पूछ लीजिए.
What is the main application of chemical kinetics?
Sir, chemical kinetics is used basically as a part of physical chemistry, and chemical kinetics constitutes a very important part of physical chemistry. It discusses about the determination of rate of the reaction under a given temperature, pressure, and concentration. So in a complete study of a chemical reaction involves 4 questions. One, how the reaction proceeds, if the reaction is feasible or not, how much extent the reaction occur, and what is the probable mechanism for a reaction. So the probable mechanism for a reaction can be guessed from chemical kinetics, and also how much a reaction, how fast a reaction does occur can be also known by the chemical kinetics. So the application of chemical kinetics is basically the determination of how fast or slow a reaction is, and to make the reaction more faster or more slower according to our desire can be studied from the chemical kinetics. So this is the main application for chemical kinetics.
What is rate? How to determine rate?
Sir, rate is the change of concentration per unit time or per very small interval of time. So if we write what is rate, then rate is equals to change in concentration by time. So how do you determine rate? So in case of chemical kinetics, to determine rate, there is a rate law. So what is rate law? Rate law says that the rate of a reaction is proportional, directly proportional to the concentration of the reactant raised to the appropriate power. So rate varies as power of concentration alpha. So if A is reacting and producing P, so in this case rate will vary with the concentration of reactant, and it will look like this. And also rate can be determined by seeing the changes of concentration of reactant per unit time. This is also rate, and rate is always positive. So this is why when dissociation of reactant is take place, this is why we use negative charge behind in front of the rate for the change in concentration for reactant. This is how we get the value of rate.
Yes. Yes, experimentally, graphically represent of rate of reaction, reversible, irreversible reactions, simple rate time, concentration versus time.
For a reversible reaction, this is rate forward and this is rate backward. And this is time. So for a reversible reaction, the plot between rate versus time will be looking like this, that firstly the rate of the reaction will be more as the concentration of the reactant is more, then gradually the concentration of reactant is getting decreased, so the rate of forward reaction will also decrease and RB will also increase. So after some time it will match the RF and RB, and the position when RF and RB will be equal, then we will call it as the equilibrium, because we know that chemical equilibrium is a state where the rate of forward reaction and the rate of backward reaction is equal. And also if we see that the rate of equation, rate of a reaction which is according to with respect to time, in case of first order reaction, then this will be the graph dAdt versus T. तो आप देख पा रहे हैं मेरा
Yes, 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 I see. Yes, I see.
This is the rate versus time graph for reversible, and this is for the first order reaction.
Yes, what the difference between rate of reaction, rate of equation, rate law? Explain any one point.
Okay, so sir, rate is basically the change in concentration with respect to time or per unit time. This is rate. And what is rate law? Rate law is basically saying that the rate, which is a parameter, it is proportional to the concentration of the reactant which is involved in the reaction to the to raise to the appropriate power. So this is rate law, where rate varies as concentration of reactant to some certain power, and rate is basically concentration, change in concentration versus time, and rate equation is basically we get from the rate law when we use the constant. This is rate equation, this is rate, and this is rate law.
Yes, next move on. First order, zero order, first order, second order, third order. Can we explain with graphically rate versus concentration, concentration versus time, and with the explanation one by one.
So if a reaction which follows this rate equation, where rate is equals to k into a to the power 0, the reaction is basically a to t. Then this is a zero order reaction. So for a zero order reaction, we will see that the concentration versus time graph will be according to the rate equation of zero order reaction, which is like this. In this case, intercept is a0 and slope is minus k. This is zero order, and for first order, and also the rate versus time graph, this will be like this, because the rate will be always equal, or it doesn't change, as it doesn't depend on the concentration of the reactant. And for first order reaction, rate equals to k into a to the power 1, and in this case a by a0 versus t. The graph will be like this, because the rate equation of first order reaction is looking like this, as a by a0 from here is e to the power minus kt. This will be also the same plot for rate versus time graph, and concentration versus time graph will be same for the first order reaction. This is first order, this is zero order, and the example for zero order will be 2Hi plus H2 plus I at gold surface. This is the example for zero order reaction, and for a reaction which is first order, then we will use 2H2 plus 2O2. So the decomposition of hydrogen peroxide is first order reaction. Sir, can I rub?
Yes. Yes, good. Carry on.
Sir, in case of second order, the rate equation is 1 by A equals to 1 by A0 minus KT. This is the rate equation, and the graph for concentration 1 by A versus T will be looking like this, as this is the slope, minus K is slope, and 1 by A0 is intercept. And we can also get the direct relation of A, but it will consist a mixture of expression, but then the equation will be more difficult to plot. So we can use, or we get A by A0 plot versus T will be looking like this. And an example for second order reaction will be the opposite reaction of HI decomposition. So H2 plus I2 equals to 2HI. This is the example for a second order reaction, and this is the graph for concentration versus time graph for second order reaction. Okay, sir.
Yes. Second order, yes. Third order?
Third order.
Yes. Rate versus concentration versus time. And other question is half-life of 0 for second, third, and difference between pseudo order reaction. Last one. यस 1 मिनट रह गया है आपको, इसमें आप बता दीजिए, बाकी आप नाइट में ज्वाइन कर लेना आपका, क्योंकि कंप्लीट मैं करा ही दूंगा। आप 10:30 के बाद एक और मॉक ज्वाइन कर लेना, ठीक है ना?
ओके ओके सर।
उससे क्या आप 12 को जाएंगे ना? 12 को कितने टाइम?
12 को मैं तो सुबह को जाऊंगा।
कोई प्रॉब्लम नहीं है, कोई नहीं, आपका अभी 2 हो गए अभी। नाइट में आप 10:30 के बाद ज्वाइन कर लेना, उससे क्या है कि आपका पूरा करा दूंगा फाइनल, है ना, जिस हिसाब से सब रिवाइज हो जाएगा पूरा, ठीक है ना? कल भी टाइम है, अभी तो 10 और 11 2 दिन है, उनमें करा
हाँ,
देंगे।
जितना प्रैक्टिस हो सके उतना ही अच्छा है,
यस
क्योंकि कुछ ना कुछ वो लोग तो पूछ रही है।
यस, आपका सारा करा देंगे, जितनी नए नए इंटरव्यू क्वेश्चन आए वो भी प्रैक्टिस करा देंगे, ठीक है? अभी तो ये हो गया है, बाकी इसका हम डिस्कस करेंगे नेक्स्ट 10:30 के बाद, जितना